This is Ritik, and I am about to demonstrate you the infrastructure that I provided using my Terraform code. So out here in the project directory, we have few files which are mainly main.tf. This is our main configuration file. Terraform.tf, this is basically our a file which specifies the versions of the providers that we are using. Suppose like AWS and local, like these are the providers. These are or providers or a plugin. So basically, these are plugin and these are the versions that we want to specify to Terraform, like only use these versions of the providers. Okay, and then we have another file called variables. Now, variable file basically can comprise of all the variables that we use in our environment or the main configuration file or anywhere. This basically is done in order to simplify the code and the code reusability as well. And out here, so let me just show what I actually wrote in the main configuration file. This is a provider block where we specify the providers. So a data block is basically used in order to fetch information about our infrastructure or anything from the provider that we are using. So out here, AWS availability zone is basically a resource type, and we are fetching what all availability zones are available in US East 1. And then we are also fetching the region, we are also fetching the instance type. And now out here, there is another data block which actually fetches the newest version of the Ubuntu image. And out here, what we can see is like, yeah, we have some filters and the name, the value is Ubuntu. This is basically the image uh, path that we are downloading the image or getting the data of the image from. And then we have a locals block. So locals block is basically used in order to like input the values or save values which are used in our configuration file. It is similar to variables, but locals provide more functionality to a variable. So these are the variables that we can use often, quite often in our uh, configuration file, and then we can just refer it by using locals dot. And later on I'll just show it to you like where exactly we are using that. And then we have a resource block where we are actually defining a VPC. We are building an VPC with the name deployment environment, and the region would be the region that we are fetching from the data source. This is a data block, that this is the one that we were referring to. Okay, so AWS region is referred out here, as you can see, and also in the server name. So we have the name of fetching so we are fetching this VPC underscore name from the variables file. I can show you VPC name here over here. So this is the default name is demo VPC, and out here that's what we are referring the VPC name as. And then the environment would be this in Terraform true, and then deploying a public subnet. So within a virtual private cloud, we have subnets. It could be private and public. And out here, basically this is used for dividing our network. So we would be creating into subnetwork. So we are creating a subnetwork by the CIDR block. CIDR block is this over here, and this is actually an inbuilt function which actually divides the IP, not the IP, but actually the variable subnet CIDR block into sub CIDR blocks. So this is our main CIDR block, and this block would be divided into different small chunks of subnets by increasing the bit by increasing the bit by 8. So here the next value would be in dot 0 dot 25 dot 0 slash 24. Oh, this is the one that we are referring to. That's why I was getting confused. I was sorry about that. Yeah. So this is the CIDR block we are referring to, 10 dot 0 dot 0 dot 0 by 16. And out here we are dividing the CIDR block by 8-bit. We are increasing the 8-bit, so our CIDR block would be 10.0.1.0 slash 24, and that is the CIDR block for our subnet. That's how Terraform basically divides CID block. And then we have availability zone, and we what we are doing out here is we are specifying that build an availability zone. Uh, inside every availability zone, build a subnet. Okay, and out here in the availability zones, let me search it. Yeah, we have defined it as US East 1A, and then in US East 1A we would be deploying in subnet by the name public subnet. And then we have route table, which would be used in order to connect it, like basically divert our traffic from the internet to our public subnet. And how we do that is basically AWS provides an internet gateway in order to divert the traffic from the internet to our public subnet. And we have defined internet gateway as a resource down here, as you can see. And so yeah, let's go. So basically the route table is defining that anything coming from this address, which is the internet, anything that comes, we have to divert the traffic to the internet gateway, and we are fetching the ID of the internet gateway. So ID is basically an argument, reference attribute argument, that we can use in order to fetch the information from our resource block. And then we have certain tags to it. And then this is the association that I was talking about. Uh, Here we have associated our route table with our subnet and the internet gateway. We have defined it over here. Now we are also launching an AWS security group. Uh, so what exactly is it? So security group is basically used in order to control the traffic on our EC2 instance that we would be deploying later. Okay, so a security group controls the traffic. Like if anything is, this is used for ICMP for pinging access, like whether we can access the VPC or not. And then we have certain rules to it. Ingress is for incoming, egress is for outgoing traffic. And then we are also generating a private key by using resource TLS private key. Now, what exactly is this? Though, so this resource is actually defined under our. Let me just show you the Terraform providers block. So this is the one. TLS is basically a plugin that we are using in order to generate a key that would be in RSA format, and then we are using a local file. Local file is basically a submodule in locals provider, okay, as you can see out here. And then we basically, what we do with the local provider is that we are able to, like make any configuration changes or allow, like basically modify our key, which is actually saved in the local. So using local, we can manipulate our data on the local system that we have. And then we are generating an AWS key. uh, so basically, when we generate the AWS key, this is the key that we would be using as the AWS key. And we have, as you can see, the public key is TLS private key, and then generated public key for OpenSSH. This is basically the key that would be used. That is being uploaded to AWS basically. So this key is basically being uploaded to AWS, and now we have other security groups for allowing the traffic which might be coming to our Jenkins server. So what we are, I'll just tell you the entire thing that my application is doing out here, but let me just describe the entire format or like configuration for my main file. So out here we have other security groups that would be attached to our EC2 instance, and this would be used for SSHing into the machine, which is for like port 22, and then we have another port open for 80 that would be for allowing the web traffic, and then the port for 8080 for allowing our Jenkins traffic, and then 443 that is for like HTTPS, and then egress would be like everything. We are just allowing everything to the internet. We are not bounding it. So now I would tell what exactly my application or my Terraform code is doing right now. My Terraform code is deploying a virtual private cloud, and it is deploying a subnet. It is also deploying an internet gateway. We are associating that with our subnet, and then we are also deploying an EC2 instance. So the EC2 instance name is web server out here, and we are using this resource block in order to deploy an EC2 instance out here, and the AMI would be fetched from the data block that I showed earlier. The instance type is T2 micro. I would rather make it T2 medium. Yeah, let's do that. So we have a T2 medium out here. I'll just save this. And now the subnet ID is this. And then the security group that we are attaching to our EC2 instance is like mentioned over here by one. The associate a public IP address is true. So what it does is it associates a public IP once our machine is spinned up. And now we are also mentioning the key name, which was the same that we generated earlier via TLS, and then we uploaded to the AWS, right? So we are using the same uh, SSH key or the public key. And then we are using a connection block in order to connect or bind that uh, key that we actually generated with our EC2 instance. So whenever like we want to access it, we can use that private key in order to access the EC2 instance. And now there are some tags, and the life cycle is this is basically even if the security group changes, like it doesn't really ignore any changes to the EC2 instance or vice versa. And out here, I'll just show you what exactly happens when we do that. This is the code that I ran earlier. So let's just, oh, so everything is cleared. So what, sorry. So what we do is, after writing or modifying any changes to our any of the configuration, what we do, the first uh, command that we run is terraform init. So this basically initializes our configuration file, downloads a module, and formats it, like downloads the providers and all the functionalities which are required in order to run our Terraform configuration file. And then we would do Terraform FMT in order to format our Terraform code perfectly. So as you can see, like our main.tf was formatted, and then we would run Terraform validate in order to validate our configuration file. This basically tells us if there is any error or not. It doesn't really tell us whether there would be an error in the deployment of the infrastructure, but it tells us whether there is an error in the configuration that we wrote. So that would be our code. And then we would be running Terraform apply. Before that, we can use Terraform plan. So basically, what Terraform plan does is like it gives you a plan of how things might look, or the infrastructure that you want to deploy might look. So this basically gives us an insight beforehand whether there would be an error while deploying the infrastructure or not. So out here, we ran Terraform plan, and it is checking and creating everything. So as you can see, there is one change that we want to make. So sorry about this. I actually deployed this infrastructure earlier, but as you remember, I changed one thing in that, and that one thing would be this, false to true. And I also changed, just give me a second. Yeah, so as you can see, we changed our instance type from T2 micro to T2 medium, and that's a change that we want to apply. And if I really want to apply that, I can do Terraform apply. And after doing this, Terraform would ask me whether I want to make any changes or should I actually approve it or not. And we would be prompted exactly like this, and then we type yes. We can also input Terraform apply hyphen auto approve. That basically prompts yes automatically. And let's see. Oh, so it is destroying the web server that we created earlier, and it would be launching a new web server that would be IC2 instance with a size of T2 medium. So in that machine, T2 Medium, we would be basically installing our Jenkins server, Docker, and then we would be we would deploy an EKS cluster through our Terraform code as well. So this is the first part of our uh, basically infrastructure deployment, and then I will be updating you guys with another Terraform configuration that would be used in order to deploy a Kubernetes cluster, Elastic Kubernetes service. So this is a managed service, which is managed by AWS automatically. So the control plane is managed by AWS, and the worker nodes are deployed to us, and we are the one who manages it and connect to the main control plane. So the Elastic Kubernetes service is what we would be deploying with our Terraform code later. So that's it for now. But before that, I'll also show you how we can actually check out the state of any infrastructure or any particular service. I'll show list in order to see how many resources are actually deployed, and these are the resources which got deployed. And now if I want to check any particular resource that I want to look out for, the command would be terraform state show, and followed by the resource type and resource name. So it is an AWS. I'll just copy this. Control C, and we followed with the dot though. Yeah, enter. So let's see whether we are able to fetch the information or not. And then I'll also show you how like can we access the EC2 instance with the SSH command. Yeah, as you can see, we have our instance running with an AMI which we fetch from the data block, and then we have it running in the US East 1B, and then the corals do, and all the rest of the other information. So what we really want out here is we want a public IP in order to access it from our machine, right? So let's copy this. And also, as you can see, in this in this directory, sorry about that, in this directory we actually have key out here, my aws key.pem. So this is a key that we generated from the TLS provider that we mentioned over here. So the name of the key is my aws key.pem, and we are also giving the permission as 600 in order so that we can actually use this key in order to SSH or EC2 instance. So the command for SSHing into the EC2 instance is SSH minus I, that is, and then we type our key, and then followed by Ubuntu, like the web server name, and followed by the IP. Let's see whether we are able to access this or not. Yep, voila. As you can see, who am I? PWD. So we have successfully SSH into our machine, and this is running over here as you can see. Let me just show you. Hey, where is my? Oh yeah, here it is. So let's refresh it. So an instance is running out here, as you can see, web server EC2, and this was the older one that got terminated. And I can also show you the VPC that we actually deployed, and the internet gateway and all the rest of the subnets. It would be shown over here, your VPCs. This is the demo VPC that we launched, and let's click on it. And as you can see, this is the beauty of Terraform. It really hardly took like minutes, not even minutes, in order to launch this entire infrastructure. So the beauty is like we have to write code once, and then we can use that code in order to like deploy this infrastructure in like infinite times, how many times you want, and literally within few seconds. So that's the beauty of Terraform. This is the demo VPC, the public subnets that we created, and then the route table association, and then the internet gateway that allows traffic. uh, Also, let me show you the internet gateway. Here it is, IGW. So yeah, that's it for now. I'll follow up with you guys and give you a brief description about how we can deploy an EKS cluster using Terraform. Thanks till then. Bye bye.